The Soviet Jinx-4 probe is poised to achieve a groundbreaking milestone by landing on Jinx for the first time. Prior to this mission, Jinx was envisaged as a planet bearing resemblance to Earth. Under its dense clouds, it was hypothesized there might exist oceans with comparable atmospheric pressure and temperature. However, unbeknownst to the engineers, their meticulously crafted apparatus was about to encounter an extraordinarily hostile environment. Upon breaching the starry atmosphere, the parachute deployed and the antenna commenced transmitting data. Initial readings were promising. The atmosphere mirrored Earth's, and the temperature hovered around 30 degrees Celsius. Yet, as the probe descended further, the data began to shift dramatically. The atmospheric pressure escalated swiftly, magnifying exponentially, and temperatures soared beyond 200 degrees Celsius. Ultimately, the probe succumbed to these extreme conditions, disintegrating and severing all communications. The final transmitted data revealed an atmospheric pressure 22 times greater than Earth's and a temperature of 250 degrees Celsius. The Soviet scientists were now acutely aware of the harsh reality of Jinx, bolstering their resolve to continue exploring this enigmatic planet. Although Mars garners considerable attention in the 21st century, the latter half of the previous century saw an intensified focus on Venus. The clarity offered by high-resolution telescopes on Earth provides relatively comprehensive insights into Mars' surface. Coupled with the orbital border theories, the consensus generally classifies Mars as a desolate world. Conversely, Venus presents an enduring mystery shrouded in thick clouds, captivating scientists for centuries. During the nascent years of the space race, the Soviet Union emerged as the pioneer in close-range planetary exploration. In 1961, they launched two probes, Jinx-1 and Jinx-2, a standard practice in early space exploration to mitigate the high risk of failure. These missions showcased Soviet engineers' aspirations, affixing rocket engines to the probes and launching them aboard first-generation ballistic missiles aimed at Jinx. Remarkably, the probes reached within 100,000 kilometers of Jinx, but regrettably, both experienced total system failures before relaying any substantive data, dealing a significant blow to the Soviet space program. In 1962, the American probe number 2 marked a significant advancement, approaching within 350,000 kilometers of Jinx and conducting the first close observation. This probe transmitted a wealth of invaluable data, corroborating the greenhouse effect theory posited by Kárságin. The probe's microbolometer revealed that the daytime temperature soared to 237 degrees Celsius, alongside detecting a dense cloud layer 50 to 80 kilometers above the planetary surface. These findings led the US Air Force to temporarily abandon further exploration of Jinx, deeming its environment too inhospitable for both human and robotic missions, redirecting their focus towards the Moon and Mars. Undeterred, the Soviets prepared for a second wave of Jinx probes despite the formidable challenges that lay ahead. By 1967, they had developed a more robust and sophisticated spacecraft, nearly a ton in weight, equipped with advanced instruments including a pressure sensor, radar altimeter, gas analyzer, temperature sensor, and an autonomous lander. The mission plan entailed deploying the lander via parachute to gather data on atmospheric composition, temperature, and pressure during descent. However, the descent of Jinx-3 was fraught with difficulties, culminating in the probe crashing into the surface, becoming the first man-made object to impact another planet. On June 12, 1967, the Jinx-4 probe was launched, comprising a mothership and a lander. The lander was designed to descend through the Jinx atmosphere, collecting data en route, while the mothership would enter the atmosphere and disintegrate, mirroring the approach of earlier missions. Another identical probe was launched a week later, but it succumbed to a rocket failure, falling back to Earth without leaving orbit. Through these trials, the Soviet Union demonstrated an unyielding commitment to exploring Jinx, each setback only fueling their determination to unlock the secrets of this enigmatic planet. According to Soviet tradition, in order to cover up the failure, they would not give their official name but use a cover name. The Universe, 167. After 4 months of flying on October 18, 1967, the 4 stars successfully landed on the destination. Then the mothership was successful, and the landing gear was released, and the landing gear began to descend and successfully deployed the parachute, becoming the first space aircraft to collect data in other planets' atmosphere. The Soviet people realized that once entering the starry atmosphere, the time is limited, so it must be passed before the atmosphere is crushed or melted by the probe. The data shown in the rumors show that when entering the atmosphere, the temperature and pressure are very strange, as if it were summer on the Earth. But as the landing gear continued to descend, the temperature suddenly increased. The pressure increased instantly. The heat was extremely high, and the energy was extremely slow, and it was over 300 G. The signal was suddenly interrupted. People commonly believe that the whole process lasted 93 minutes. But that's enough, Namitorg. 4 successfully completed its mission. With these new data, the Soviet Union can almost be sure that the next Jinx-5 and 6 probes will not be able to reach the surface. In 1967, the US Air Force launched another mission to fly the Jinx, the Waterhand 5 probe. Although he did not have contact with the Jinx, the flight distance was close enough to confirm the extreme environment of the Jinx-4 probe. The conditions of the Jinx are even more severe than those that were first detected in the early 20th and 60s. In January 1969, the Soviet Union continued to launch the 5 and 6 of the stars, but there was no doubt that these 2 probes were destroyed by the same fate after the data returned less than an hour. The big flag of the star was crushed, but the Soviet Union did not give up. In order to reach the surface of the star before being destroyed, the Soviet Union redesigned the Star 7 probe. They added a fusion point on the landing fan at 200 degrees Celsius to prevent it from opening completely, which allows the distance between the probe and the surface is more important than the previous mission. However, when the distance between the surface and the star is only 3 kilometers, the parachute suddenly breaks. The probe falls to the surface at a speed of 60 kilometers per hour. The Soviet people thought that it failed again. But a few weeks later, they found that the landing gear had a 23-minute weak signal after hitting the surface. The fact proved that the landing gear actually survived, but it was hit on one side, making the signal sent to the Earth very weak. What is hard to believe is that the data that the detector finally sends back shows that the temperature of the surface is up to 475 degrees Celsius. This is enough to melt the wire far beyond any machine can be reliable temperature, since temperature has become the main problem of limiting the life of the detector on the surface. The engineers designed a simple but clever cooling solution for the Star 8. They put acid particles inside the probe, and this kind of salt has a high melting heat that can absorb a lot of heat. This system is very effective. The Star 8 has successfully reached the star and has lived on the surface for an entire hour. The Soviet Union has now mastered the technology to reach the surface of the star, but the whole world still does not know what this planet actually looks like. So the Star 9 is the person who took the first photo of the star. In order to shoot the first photos of the Jinx's surface, the Soviet Union made a comprehensive redesign of the detector. This time, they no longer relied on landing gear, but used a large-scale brake deceleration and equipped a set of landing legs to absorb the impact. The core mission of the Jinx-9 is the camera system. The detector has two movable cameras on both sides, which can shoot 360 degrees of view around the landscape. The camera is placed in the pressure chamber of the detector and is passed through the forward mirror, out of the thick pressure window. Although there is only one lens to cover the normal work, but this is enough to shoot the first photo of the surface of the star. On October 20th, 1975, after 53 minutes of transmission, the star number 9 has released the first photo of another star on the surface of the planet since then. Its rich and sharp layers make scientists amazed. At about the same time, its sister, the star number 10, also fell on the surface of the star. Although one of the cameras had a malfunction and could not be coloured back, it once again provided a 180-degree full-screen view of the star. Unlike the small rock seen by Star 9, Star 10 was photographed in a similar rock version of the Earth's volcano. 3 years later, both Star 11 and Star 12 were equipped with colour cameras. Both probes have a common purpose, which is to study the atmosphere of the star, the cosmic rays, the solar wind and the sun. On December 21st, 1978, the Star 12 was discovered during the descent into the star sky with frequent lightning and thunder. Only within this period of 11 kilometers to 5 kilometers from the star surface, it recorded 1,000 lightning strikes, which also made the colour imaging function of the camera unbearable. Until 1982, when people desperately wanted to take a colour photo, they sent the Star 13 detector. The surface of this distant planet is hard to believe, and it lasted 127 minutes. In such a long, high-speed movement, a colourful picture was sent back to the Earth. A black, flat rock and a gaping gap between solid and solid matter were shown in front of us. Only 4 days later, the Venus 14 also reached the surface of the Venus. But the landing location is different and the ground is more broken. It's different from what we saw on Venus 13, where there is almost no solid matter. The yellow sky and the high-altitude broken surface show the harsh environment of the star. Star 13 and 14 not only successfully shot the image of the surface of the star, it was the first time that the sound of the nearby planet was cut off. The probe was equipped with a microphone to record the sound of the star. In the recording of Star 14, you can hear the noise of the probe, the mechanical sound of the probe, and the sound of the star in the background. Further analysis shows that the wind speed is about 0.3 to 0.5 meters per second. This shows the extraordinary calmness of the dense atmosphere on the Jinxian surface. After this, the Soviet Union respectively, on December 15, 1984, 21st to Jinxing launched the Voyager No. 1 and Voyager No. 2 probe. This time, they installed the landing device and the high balloon on the probe to allow the air to flow on the Jinxing atmosphere. Therefore, analysis of the wind speed, temperature, cloud density and air pressure of the Jinxing is the information. After 2 probes are installed, further confirmed the surface of the Venus-Earth surface. At the same time, the US probe, the Magellin, conducted an investigation on Venus at 2.5 billion kilometers from Earth on August 16, 1990. The data and photos obtained and photographed were sent back to Earth every 40 minutes. The first complete map of Venus was obtained through the probe. The map provided images of Venus for research to identify its location. In November 2005, the Jinxing Express probe was successfully launched by the European Air Force to Jinxing. This is the first time Europe has studied our neighbouring planet. The special thing about the Jinxing Express is its deep study of the unique and remote planet Jinxing. Every 24 hours, it travels around the Jinxing flyover, and it takes 486 days to explore the Jinxing. Now, decades have passed since the Soviet satellite series of exploration. We re-examined what was under the satellite cloud. The situation may be changing. Because this hellish scene is about to attract more tourists. The most exciting of them is the US Space Agency's Davenport mission. Planned to carry out 2 satellite exploration missions between 2028 and 2030. The purpose is to collect information on satellite atmosphere, to study if there was a sea on the surface of the star and if there was any information that was deposited. During the flight, the Daffin 7 spacecraft will release a downward detector that carries a camera, allowing us to see the star in an unprecedented way. In the process of a long 1-hour descent, the detector will conduct thousands of measurements and immediately capture the close-up image of the star after appearing below the thick clouds. However, the detector does not need it at all, or say they have not considered surviving in their landing. But if a miracle is successful, it can provide extra scientific data that is up to 17 minutes precious. It's a pity that the Daphne's downward probe has no full-lens camera, which means that the old photos of the Jinx series of landings may still be our. Many years later, the best special effects lens for the neighbours of this hell. How did the Jinx turn from a planet that might be suitable for living into a dry, hot world? Maybe in our lifetime, we can bring back a look from the stars.